Okay, so this is example 3.6, and we're going to get at the issue here of potential energy and kinetic energy and how they relate to each other. A girl on a swing is 2.2 meters above the ground at the end of her motion and 1.0 meters above the ground at the lowest point. What is the girl's maximum speed? Okay. Well, it doesn't look like there's a lot of information in there, but there actually is. The two numbers that are given, there's two heights, right? So we have to figure out which height we're going to use. Essentially, what we would claim is that when you're on a swing, if you're just sort of sitting in the swing and you're not moving, you're down at the bottom of the motion, right? Remember, a swing goes back and forth. If you're just sort of sitting at the bottom there, you're off the ground. You might be off the ground by 3 feet or a meter, okay? So that's what's happening here. You're off the ground. Now, technically, you do have some potential energy because you're a meter off the ground. So if you fall, you will experience that there's definitely energy there. But in terms of the motion, now what you're going to do is you're going to start at a meter and you're going to swing up to 2.2 meters. So you're going from 1 up to 2.2 meters. Okay. Well, what happens is that height difference is a difference in potential energy. You have less potential energy at 1 meter. You have more potential energy at 2.2 meters. And that is essentially, that potential energy is what is converted to kinetic energy that allows you to move in this, back and forth motion, right? So you go from 1 up to 2.2, back down to 1, up to 2.2 on the other side, and then back and forth. So what we can do is we can calculate the potential energy of the swing. And the potential energy of the swing is gravitational. It's just mgh. Okay. So now we have mgh. But you might say, well, wait a minute, we don't know the mass of the girl. We don't know the mass of the swing. But we do know what g is. And we do know that h is 1.2 meters. Again, it's the distance or the height from the lowest point up to the highest point. That's the potential that's going to give you the motion. Okay. So we do know that this is m times g times 1.2 meters. Again, 1.2 is 2.2 minus 2.2 meters minus 1.0 meters. Okay. Now, what we're going to claim is that potential energy is now going to get converted into kinetic energy as you fall down, right? Maximum potential energy, no kinetic energy at the top. But then you come down, you start going faster, right? So when you reach the minimum, which is 1 meter above the ground, that's when you'll be going the fastest. There are frictional losses in the swing. We're not going to, there's air friction and all that. We're going to ignore all that. But what we can say then is that mgh that's the amount of energy that's going to give you the kinetic energy of the swing. It's going to be converted, right? It's really an issue of the law of conservation of energy. All that potential energy doesn't just disappear. It gets converted into kinetic energy. So the maximum amount of energy we can have in terms of kinetic energy is the same amount of energy as the potential energy, which is mgh. But kinetic energy is 1/2 mv squared, right? So here's what we can do then. We can say that mgh is equal to 1/2 mv squared. And look what happens to the m. The mass cancels. So now you've got gh equals 1/2 v squared. So we don't need to know what the mass is, okay? The question is, what's the maximum speed? What's the velocity? Well, that would be the case where all the energy has been converted into kinetic energy. So we want to solve for v. So what I'm going to do first is I'm going to multiply by 2 on both sides. 2 times 1/2 is 1. Okay, so now you have 2gh equals 1 times v squared. Now we want to take the square root of both sides because that will give us v. Okay, I just took the square root of both sides. That gets rid of the square and gives you v. So now it turns out we didn't need to know what the mass was. So our velocity is going to be the square root 2 times 9.8 meters per second squared, that's g, times 1.2 meters. Okay, so let's go ahead and calculate that. 2 times 9.8 times 1.2, take the square root. 4.85 meters per second. Okay. So in other words, you go up. Once you reach that maximum, you're not moving at all. Your velocity is 0. You come back down. Your maximum velocity is 4.8 meters per second. Then you go back up and you slow down, slow down, slow down until you get to the maximum and you stop. 0. You come back, down, down, down. Once you reach that minimum, you're at 4.85 meters per second. Back and forth.